Hello, my name is Muhsin. I'm the head of physics at Newstead School. It's my pleasure to welcome you to this taster lesson in science. To me, science is all about finding things out. It's a great pleasure because you find out. Science is very important to understanding the world inside us, like our body or our mind, the world beyond us, and the world surrounding us. Here is a biology activity.
Right, hi and welcome to biology. I'm going to be just demonstrating a practical that will be one of the first ones that you do actually in September when you start school. And we're going to be using the microscope and we're going to look at onion cells. So the first thing we need is a very small thin piece of onion. And it has to be very, very thin because when I switch the microscope on, you might be able to see light shines up through the sensor here, through the lens and up through the eyepiece, and so this needs to be thin enough to allow light to come through. So the first thing is to get a nice thin piece of onion. Try not to cry. There we go, so you can probably see here, very, very thin piece. We then need a glass microscope slide and a small drop of water, just to stop it drying out so that when we actually look at it we're seeing what is really there. That needs to be now put nice and flat, which this one isn't. Right, so you've probably talked about what makes a living thing, moving and reproducing and eating and things like that. Well, one other thing is that they're all made of small structures called cells, which is what we want to see here on this slide. Now the problem is that they're more or less colourless, so we need to be able to see the structures underneath, so we're going to stain it with iodine solution. So next thing is a few drops of that. On. Need to be careful because this is a stain, so it will stain clothes and fingers and everything else. Then we need what is called a cover slip, which is a very tiny, tiny square of glass, and very, very carefully lower that over our sample. Now the reason you need to do it so gently, and you probably couldn't see that actually because I was in the way, but put it down with this needle, is to try and avoid trapping air bubbles. And push that down carefully, and then lots of it's oozed out. So I need to take a bit of blotting paper and just soak up the excess. You might actually notice here the paper, although the iodine is this brown colour, the paper is actually going bluish black colour. That's because there's starch in it which changes colour. So this will need to go under the microscope and clipped in place here on these clips. Then these knobs here are for focusing, so we start with them all the way up. And then while looking down the microscope, we just slowly move it until everything comes in focus. Like that. Now obviously we can then change these lenses to get zooming in with higher and higher magnification. You can't see down the microscope, so what I'm going to do now is move it to a microscope connected to the computer so I can actually show you what you should be able to see. So I'll be back in a moment. Right, okay, so you can see this microscope here. We've got the camera attached to it, and my onion slide is now underneath. It's all switched on and ready to go, so hopefully when I switch on the screen, we should be able to see what's underneath. I'll just turn the lights off. And right, so I apologise for the wobbliness. I've had to start walking around the room with my phone, but you can see here the actual onion cells, and these are the cells joined together that make up the entire onion bulb. The only structures you can really see clearly on this, the outline of each cell, is a structure called the cell wall. That's only found on plant cells, and it gives them a great deal of strength and holds the cell in shape. And the iodine has stained the smaller structures within them, the sort of orangey colour. That's the nucleus of the cell. It's in the nucleus that the DNA, the genes, are found, and that controls everything about the cell, its structure, its functions, and everything that it does entirely. And it's that material in each one of those nuclei that has all the instructions for making an entire onion plant. So in September you'll see a lot more of this, and we also will take it one step further and have a look at some of the cells from actually inside your cheeks. But I hope this has been just a small taster as to what you may well be doing in September, and look forward to seeing you then. Thank you.
Hello and welcome to Science in Newstead. What we're going to do today is a little look at how to use indicators. So indicators are things that tell us if something is acid or alkali or neutral. Okay, so neutral pretty much means it's not going to be harmful to your skin usually. Acid is a bit dangerous, and alkalis can also be dangerous. We need to know if something is acid or alkali or neutral. Now, you can make indicators relatively easily. You can actually make indicators out of plant material. So I'm going to be using some red cabbage juice, which is fantastic. But just to show you how you can make it, I'm going to use some beetroot. Okay, it works the same way. So if you're using some beetroot, or you're using some red cabbage, or some flowers like hydrangeas also change colour depending on if they're acid or alkali or neutral. So you get whatever vegetable material you've got and put it into a pestle and mortar. There we go. So here's my pestle and mortar, and right, top tip, don't do this, push and twist. Okay, so I'm going to do a bit of push and twist, push and twist, push and twist. And already the beetroot is giving out quite a lot of juice. Okay, if you want to encourage it further, you can add a little bit of sand, okay, to help it. So especially with red cabbage, that helps a lot. And then to finally get all the, so there we go, smushed up. To finally get out, I've got some water, but I've got distilled water, which I've put down somewhere. Hold on 2 ticks. Voila. Right, distilled water. This is water with nothing else in it. It is entirely dihydrogen monoxide, just H2O, okay? So, I've added that, and you can see, where's the camera gone? What? If I tip it too much, it will come out. Let's get the camera, it's the same thing. Okay, right, so now you can see there's some juicy bits running about, and that is our indicator, okay? So what I can then do, I can use a little device for sucking up that liquid, and that's what we're going to use to test if things acid or alkali or neutral. Now, I prefer to use cabbage. I just like the colour changes, so I'm going to use that from now on. So I've made this in exactly the same way, okay? But our wonderful technicians have made it for me. Okay, let's put all that to the side. And here's my, okay. This is a pipette, okay? It's used for sucking up liquids. I've got here, let's move the camera. Okay, right, 3 beakers. Acid, alkali, so acid, neutral and alkali. Well, I'm trying to get all these 3 in the shot at the same time. This was acid, Okay. Oop, hold on 2 ticks. Right, acid, neutral and alkali. Okay, this is not going to work terribly well, we'll give it a go. Okay. Oh, there we go. Right, acid, neutral, alkali. Okay, acid, harmful, neutral, happy days, alkali, not nice. I'm going to use my indicator, my red cabbage, to see what colour they go. So I put the cabbage into the acid, it turns red. Okay, have a think. What colour do you think the red cabbage might go with the alkali? I'll give you a clue. It's my favourite colour. Oh, green. Okay. Oh, there you go, green. Now, what do you think is going to happen with the neutral one? Okay, let's have a little look. Okay, quite a splash in that one. So, in acid, it's red. In neutral, water, it's purple. And with alkalis, it's green. Okay. That seems fine and dandy, but what about some other things? So I've got a test tube rack. In my test tube rack, I've got some orange juice, or we'll have lemonade, lemon juice and tap water. I'm going to pause the video while I fill this up. Hello, back again. Right, so to recap, we've made an indicator and we know the different colours. Acid is red, neutral is purple, and greeny yellow is alkaline. Okay, so I'll keep this in the background. I'm testing these substances. Right, there's my indicator, and I add it to lemon juice. So what I think is going to happen with the lemon juice? What colour do you think it's going to go? And it's sat on the top a little bit, and it should go slightly reddish. So lemon juice is slightly acidic. Okay, it's not mixing particularly well, but it will go slightly reddish. Okay, next one I've got is lemonade. Let's see what happens with that. Okay, that has definitely gone a bit reddish, slightly purple, but it's also slightly reddish. And finally, I've got tap water. Not a superb colour change, but there you go. So tap water actually is not neutral. Tap water's got bits in it that make it slightly alkaline, depending on where you live. Also, I've got some washing powder. Okay, I add some cabbage juice to my washing powder. And see what happens there. Okay, check that one out. Green as green can be, definitely green. So on labels for, on boxes for washing powder, there always are labels saying do not mix with children, okay? Because washing powder is very dangerous. You must take care of it, okay? So that's definitely an alkali. Anyway, I hope you've enjoyed that. It's just a little bit of a taste as to the sort of science you can do at home, or you might do practical similar to that when you get to Newstead. Looking forward to see you then. Bye-bye.
Here we have an example with physics and chemistry together. Ready?
What's happening?
Did you see that?
It wasn't that high.
No, I know.
Every single thing in the universe wiggles, they vibrate. If there is a vibrating object, there's going to be a wave. The most familiar one is the sound waves. There are also other type of waves, such as ripples on the surface of a pond, or when you wiggle one end of a slinky, you create waves on the slinky. There are also light waves. That's what we're going to look at now. There are two types of waves. The first one is what we call mechanical waves, like the waves that you can create on a slinky, or the wave that you create on the surface of a pond when you throw a small piece of pebble, ripples. In this animation we have two slinkies, and we are creating two different types of waves, two different type of mechanical waves. Another type of wave, which is not mechanical, is electromagnetic. We call them electromagnetic waves because it is a combination of electrical and magnetic effects, which we will study full detail later. Electromagnetic waves are basically a posh name for light. When we say light in our daily life, we mean the visible light. Like, for example, here I have a mirror. Okay, let me do it this way. So you can see the visible light coming from the surface of my, coming from the screen of my laptop into the mirror, reflected from mirror to the camera. So light can be reflected, and this is visible light. What I will do today with you is I'm going to show you that there are different types of lights that we cannot see by our naked eye. So if you have your remote control with you, you can try this later and show it to your parents, your sister, your brother, your relatives to surprise them. Like, a remote control uses light to communicate with the device that it's trying to control. In this case, this is a remote control for my television set, and every remote control has that bit where the light is emitted, given out by the device, by the remote control, and that light carries information, so we control the device. So what I would like you to do is point that to you like this, you know, that bit in your eyes, press any button and see if you can see any light coming out. You can try this. Try and see. Have you tried? Okay. You won't be able to see any light. But how do you believe me then? I say that there is light coming out of there. So what we're going to do is I'm going to point this to the camera, and I will press one of the buttons. Here we go. Ready? Yahoo! So you can clearly now see some light coming out of there, which is captured by the camera. But I do the same thing. My camera, my eyes, are unable to capture it, because this type of light coming from remote controls are infrared. That's the name of the type of light that we give coming from these electronic devices. Infrared is a type of light that human eye cannot detect. But camera, being a being an electronic replica of eye, can detect them, and you can see them. And I will also show you how let me do it like this. Yeah, here we go. How the infrared can be reflected on the mirror. Here you go. You can see. So just like any light, infrared can be reflected as well. So what you are seeing right now is the reflection of the light coming from the remote control of the mirror going back to the camera. You can also hear the effect of that infrared light. Here I have my radio. This radio can be tuned to AM or FM radio stations for a reason which is beyond the scope of Year 7 science. We cannot make this radio detect the infrared if it's tuned to FM. So I need to change it to AM. AM stands for amplitude modulation. Is to do with how we can carry information through waves from the broadcasting station to your radio. So let me turn it on. Here we go. So this is tuned to AM. Let me bring it closer to microphone. There we go. Sorry for the noise, but it's not tuned to any broadcasting station right now. So let me press that button. Do you notice anything? Not really, but if I get closer to this, closer to radio, let me get this here in front. Hopefully you can hear it. If you press any other button, it would also work. It would be slightly different because different buttons send different signals, but it is very, very difficult to differentiate. Try this at home. In a minute I'm going to show you another video. Please do try it at home yourself, and it is good fun, it's interesting. What I'm trying to highlight here is that sometimes there are things that we observe which may seem like magic or magical or surprising or unexpected, but we can use science to bring a light on them, to understand what's really going on, and we can use scientific method to understand how certain things are happening. Here we go. First, on a piece of paper, draw an arrow. This is my arrow, and now you will need a glass, an empty glass, and then you are going to put this piece of paper now with the arrow on it about, I don't know, about 10 centimeters behind the glass, like this. And now, as you can see, everything is fine as expected, normal. Now I have some water. Let me show you this way. Here we go. And I'm going to put this in the glass. Ready? There we go. Ta-da! The arrow is now showing the other direction. Well, here we came to the end of our taster lesson. We all look forward to meeting you in real, face-to-face in September, and we will all share the joy of finding things out. That's science. I want to leave you with one of my favorite videos. Have a lovely day and take care.
How do you do, ladies and gentlemen, and boys and girls, and teachers? Our special business today will be on the subject of waves and sound.
To make a sound, something has to vibrate, but it won't start to vibrate by itself. First, you have to hit it. Are you listening?